with me. And we want to find the equation of the line in standard form. So whenever we see this phrase, standard form, remember this tells me my end, where I'm going to go. So AX plus BY equals C. Not only does it tell us where all the variables are, so by the way, if this is the equal sign, that tells me the sides of my equation. Notice what's over here. These are my variables. And over on the other side is my constant. That is the number by itself. And learn to spell. A constant. The constant can be any number. Usually they're integers. And this can be a 0. It's okay for it to equal 0. So I want to get all my variables to the left side, all my constants on the right side, and I do want all of these letters primarily to be whole numbers or integers. One key thing that we also mentioned is, generally speaking, the A is positive. So I would not say negative 3x plus 2y or something like that. All right, so let's walk through this, and we're going to put this in standard form. So where does everything have to be? I need to get the x to the other side because both the x and the y have to be on the right. However, I do not like fractions. So what is the surest way to get rid of a fraction in any equation? Through it. If I were to just take the 4 and multiply everywhere by 4, so 4 times the y, then 4 over here times this fraction, and multiply the 4 there. The first step, I'm going to kill all fractions. All right, so I bring down a 4y. Notice what happens here. The 4 is reduced to 1. So I bring down the 3x. And I bring down now a negative 20 because 5 times 4. So what did I do there? I cleared the fractions. And the easiest way to do that is just multiply by the LCD all across the board. If there's more than one fraction, that's where the lowest common denominator comes in hand. But here there's only one denominator, so I just multiply by that. So I cleared the fraction. Okay, next step, I do need to get the 3 to the other side, the 3x to the other side. You do not have to show this work, but I'm going to. Notice that those are not like terms, so I bring down the negative 3x. Bring down the positive 4y, and I have the negative 20 remaining. So what did I do? I collected my variables. So all my variables are on one side. So this actually looks like standard form, except generally speaking, so if the answer simply says what's standard form or what's integers with integers, this is one answer. Now, generally, though, let's make the A positive. So if I change it opposite here, then I have to opposite this and oppositify this as well. So I'm just going to take the opposite all across the board to bring down a positive 3x, a negative 4y, and a positive 20. So what did I do? I took the opposite all across the board so that A was positive. That A is positive. Now, just to give you a heads up, generally, this is what we do. However, this is an answer right here. Negative 3x plus 4y equals negative 20 is an answer, and it's a correct answer. So on a multiple choice test, for example, you might have this as an answer. Just making sure that these are all integers. So A generally is positive, doesn't always have to be. In this class, generally go ahead and make it into a positive. All right, so let me walk through number 17 because we panic a little bit when we see more than one fraction, but that's okay. The LCD, that is the least common denominator, or LCM, least common multiple, between the 3 and the 6 is a 6. So when I multiply everything by 6, it will indeed destroy all fractions. So I'm going to bring down the left side. That's exactly what we see. If you forget how to reduce this, don't bother. Just do 4 times 6, 24, divide by 3, 8. 4 times 6 divided by 3 is 8. And don't forget this negative right there. So you can reduce. The other way to do it would be to reduce this by 3 and this by 3 to get a 2. And then 4 times 2, keep the negative, is also 8. Don't forget the x brings down. And over here, my 6 is reduced to 1, and I'm left with a 5, positive 5. Now I need to add 8x to both sides in order to collect my variables. So x is going to go in the front. We go alphabetical order. Plus 6y, bring down the 5. No need to positivize the 8 as it's already done for us. Let's look at this. And one way that we can use this wonderful thing called standard form is it helps us to find the intercepts, and we can quickly graph. So when do we use this to graph as opposed to slope-intercept form? Well, notice here, the 3, the 5, and the 15. Notice that 15 is divisible by the 5, and 15 is divisible by the 3 into whole numbers. So because of that, this would be a very quick method to graph instead of putting it into slope-intercept form. So if you recollect how to do that, if I were to, remember, erase this, I get this equation, 3x equals 15. And remember, I can do the same thing, erase the 3x to get 5y equals 15. Essentially what I've just done is substitute in a 0 in those cases. Now when I divide and solve for each one, this one here, divide by 3, gives me 5. So that's my x-intercept, 5, 0. My x-intercept is 5, 0. Over here, when I divide by 5, I get 3. So my y-intercept is 0, 3. My y-intercept is 0, 3. So this one here is my x-intercept. This one here is my y-intercept. So how do I apply that? All I have to do, and let me do a quick sketch here, is 0, 3 is somewhere like here, and 0, 5 is somewhere over here, and it's going to be this line. So I know that on a scale, I have to get at least 5 along the x-axis and 3 along the y. I don't need, in fact, I don't need most of the quadrants. I don't need 3 of the quadrants much. So let me just go ahead and graph that. So my focus is going to be quadrant number 1 is here. Generally, I can count by ones, but I'm only going to write a few of those. 2 here, 4 here, 6 here. And I'll do the same going up, like so. Now, 5, 0 is this one here. And 3, 0, 3 is right here. And all we do is connect the dots. Remember, if you have a hard time drawing a straight line freehand, just pull out your ID card to do that. So our goal for today remains the same. We are still going to be writing equations of line, given its slope and a point on the line. So please turn to page 3.